Yeah, good afternoon.
Yes, sir. So, can we start now, sir?
Yeah, please.
Thank you very much, sir. So, good afternoon, all the participants. And this next session will be related to the smart materials presented by Dr. Sandeep Singhal, Associate Professor, NIT Kurukshetra. Dr. Sandeep Singhal, working as Associate Professor in Mechanical Engineering Department of NIT Kurukshetra. He also has worked with AICT for 7 years on deputation from NIT Kurukshetra. During their posting in AICT, he has worked as Deputy Registrar and Chief of Regional Southern Office. And he also worked as Chairman ISTE Haryana Chapter. He has published more than 100 research papers with reputed indexed journals, international journals. He also has published numerous books and book chapters, and he has a vast teaching experience. So, sir.
Okay, thank you very much, Professor Gyanen. And today, I welcome you all onto this FDP program on novel materials. Novel word is meaning something new. And with this new, in last year or in the year 2019, we meant novel with novel coronavirus. It was a new virus. Now we are dealing with novel materials, new materials. And before we start, or before we begin, we are into the fourth industrial revolution. First being the steam, second being the electricity, third being the computer, and fourth revolution is now automation. We are now into the fourth industrial revolution where we will be dealing with a lot of new sort of technologies, new sort of materials, new sort of systems, and new sort of thinking processes. We are working on artificial intelligence, cloud computing, robotics, additive manufacturing or 3D manufacturing, virtual reality, augmented reality, and all those things. We are now working on to that. So it is Industrial Revolution 4. By 2025, we will move on to Industrial Revolution 5 or Industry 5.0. Industry 5.0 will have a new terminology, HR. H will stand for humans and R will stand for robots. That means it will be an interface between the humans and robots. It will not be human resource. It will be humans and robotics. It will be Industrial Revolution 5 or Industry 5.0. In order to have these revolutions successfully attained, or in order to have these revolutions see the successful light of the day, there are a number of new technologies which are coming up, new equipments, new sort of softwares, and at the same time, new novel materials are also coming. Novel materials means smart materials. Smart materials means intelligent materials. That means that sort of materials which are able to think by themselves. And their thinking means which are able to adapt with the changing environment. Such as when we as a humans, what we do? We have got a brain, we have got a body. Brain thinks and body senses. If it is raining, we say that, okay, we will have an umbrella. If it is hot, we say that, okay, we are going to sit up in an air conditioner. If it is cold, we put up woolen clothing. Same way, the materials are also there. And in case they are able to think by themselves, in order to adapt to the environmental changes, they will be known as smart materials or intelligent materials. And nowadays, the time has come up when these smart materials are forming each and every, or sorry, they are involved in each and every walk of our life. So we now try to understand what is this smart material is. Smart materials which can think on their own and have mental alertness. Mental alertness here means they are able to adapt with the changes. Quick perception. They are able to gauge the changes. What are the changes are there? Speedy activity. That means they are able to react to the changes. Effectiveness. Here means they are able to deliver the objective what they basically want to have. Spirited liveliness. Spirited liveliness means they should be able to evolve themselves, able to sustain themselves, and able to progress themselves into these fields. Intelligence overall. So materials which can think on their own and have all these parameters will be termed as smart materials or intelligent materials. Materials can respond to changes are able to receive information, sense. If you compare these materials with the human body, it is the human body which senses, able to analyze and decide processes, and able to act onto the decision is actuation. So this actuates, processes, and sense, or it first sense, then processes, and then actuates the act in for which it is made of, for which it is designed for. Now, three basic components of a smart system. We have already told you that they are the sensors, they are the processors, they are the actuators. If you compare this with any engineering application, we have taken an example of a smart concrete building, which is supposed to have an end result as a suitable to earthquake areas. Sensors are there. They are the optical fibers. Optical fibers are there. They are embedded into the concrete. It senses. Processors are there. There are smart wires where they automatically shrink or expand as the need may be. And then we have got actuators. These actuators are basically the active smart material fillers preventing crack propagation. So if you take this as an example for a building which is suitable to an earthquake areas, your sensors, optical fibers, the processors, you've got smart wires, then you've got actuators. That means it will activate or it will actuate in order to prevent there is no crack propagation. So the wires they extend or they contract, so they keep the building safe. No cracks are propagated, hence no safety issues are there. And optical fibers, once they sense, they give information to these processors and actuators. Now, how do these smart materials function? Smart materials are those materials which can alter significantly their inherent properties with respect to temperatures, with respect to what you say stress, forces, with respect to moisture, with respect to electrical fields or magnetic fields. So all these things are external stimulus to which the smart materials are sensitive. They are the stresses, that is the forces, the pressures, the temperatures may be cold or hot, the moisture, that is the relative humidity, the pH values, the acidic or alkalinity, the electric field or the magnetic fields are there. So what they are doing is they are, whenever these materials are subjected to one or more of these external stimulus, they try to change themselves. They try to resist themselves. So classifications of these smart materials with respect to the stimulus through which they are affected. Structural materials, they are changing themselves with respect to stress and strain. That means the change in shape, pressures, sizes, and all those things. Electrical materials. Electrical materials means they are changing with respect to resistance and temperature relationship. Biocompatible materials, biomimics. Biomimics means they are just performing the way a human performs. Mimicry, recognition, analysis, and growth characteristics. Intelligent biological material, biomimics again a mimicry, again just mirroring the humans. Dynamically tunable materials, they are versatile. They can be with respect to light, they can be with respect to pressures, they can be with respect to fluids, they can be with respect to the pH, they can be with respect to the magnetic or electrical fields. So we are broadly classifying the smart materials of intelligent materials as structural materials, electrical materials, biocompatible materials, biological materials, and dynamically tunable materials. These are the standard classifications of the smart materials. Now, interdisciplinary of nature of the smart materials, we can see this. Smart materials and systems, they are made up of, if we start from physics in the clockwise direction, so principles of physics, fundamentals of chemistry, MEMS, E&I, CSIT, structural engineering, material science, and biology. That means all walks of life, whether it deals with the humans, it deals with the materials, it deals with the emotions even. It deals with the softwares, it deals with the structures, it deals with the instrumentation, all these things are there. And these things are combined together into a progressive directions in order to achieve something new for the benefit of mankind or to minimize the human efforts, and the materials used will be known as the smart materials. So we can see this, the smart material is not restricted to physics or to chemistry or to engineering or to computer science or to mechanical or to electronics or to biology. They are common to all. A specific type of smart materials is shape memory alloys. Shape memory alloys. That means a particular sort of shape is memorized in them, and whenever any external pressure, be it stress, be it strain, be it temperature, or whatsoever things are there, they are able to change, and once the original conditions are implied upon, they are able to take up their original shapes. Piezoelectric materials, again, piezoelectric effects we know, which is pressure generates electric current. Magnetorestrictive materials. Magnetorestrictive materials means the materials which changes their behavior whenever they come in contact with a magnetic field, whenever they come in contact with the magnetic systems, they change, even they freeze or they become liquid. Rheological fluids again, these fluids which are affected with respect to magnetic fields or electric fields. Whatsoever, in case a magnetic field is passed through these fluids, they become solid. In case it is released, they become liquid. Same way with the electric field. Thermoresponsive materials, the materials which change or the materials which alters their capabilities with respect to temperature. They are known as thermoresponsive materials. Quantum tunneling composites, QTCs. Quantum tunneling composites means they may be a combination of the above one in order to achieve something desired. Any questions to this point? Fine, I go ahead. So what are the shape memory alloys? An alloy that remembers its original cold pore shape. By heating, it returns back to the redeformed shape. Smart memory alloys are materials which can revert back to the original shape and size on cooling by undergoing phase transformations. That means in case we change the temperatures, then definitely they become or they change the shape. And again, when they are brought back to the normal temperatures, they come back to the original shapes. For example, retinol. This is one of the examples for thermal. Trephenol D, magnetic fields. All these things have been given here. And shape memory alloys are a unique class of metal alloys that can recover apparent permanent stains when they are heated above a certain temperature. Here we have got two things, austenite and martensite. You can see here, martensite, when it is heated, it becomes austenite. And when the austenite is cooled up, it becomes martensite. And martensite, you can see this, if it is further deformed, it again becomes another sort of martensite. You can see this as the temperature decreases, austenite becomes martensite, and as the temperature increases, martensite becomes austenite. Austenite is a here everything is perfectly gridded, whereas in martensite the grids are inclined, and in second martensite, which is a deformed structure, is basically a zigzag shape. So these are the shape memory alloy which can change their shape and even come back to their original shape with respect to the temperatures. Here you can see this original wire shape 1A, twisted, smart material alloys wire heated above 90 degrees centigrade, and once it returns to the original shape after cooling. अब आप ये देख सकते हैं वन के अंदर हमने एक फोल्ड एसएमए वायर राउंडेड स्टील जिग बनाया एंड पास करंट थ्रू इट, एक zigzag शेप में हम कर रहे हैं. Change shape of SMA material, place in hot water, and when it is placed in hot water, it becomes or it returns back to its original shape. You can see this is a zigzag wire. So this way the temperatures are there, which changes these smart material alloys. And these are some of the physical properties of these smart material alloys. For retinol, Se508 wire, the melting point has been given. In degree centigrade, density has been given, electrical resistivity has been provided, MOE has been provided, coefficient of thermal expansion has been provided, mechanical properties, super elastic properties, and composition. It is the nickel, titanium, oxygen, and carbon. These are the four ingredients of retinol, nickel, titanium into the system of oxygen and carbon. Now, smart material alloys, they are used in robotics. You can see there is a muscle wire. When a small current is passed through the wire, it becomes much harder and returns to its original length with a reasonable force. That means if you want to lift something, just put the wire and this smart muscle wire, pass the current and it becomes tight and it lifts the weight. Again, if you remove this current, what happens? It leaves. So electricity is also one of the major factors here, which is responsible to actuate mechanism with these wires. And this is important here. A battery and switch are connected to muscle wire and a small weight stretches the muscle wire. The cycle of turning on and off the current has the effect of lifting and lowering of these things, the weight. You can have this robotic hand even. Robotic hand, whenever, see these, you can see there is a hand, and in this hand, the smart wires have been fitted. And these smart wires, whenever they are actuated with the help of electricity current and they become muscle wires, then they are trying to actuate and movement of the hand is given here. So you can see there here that smart material alloys are basically trying to actuate the robotic hand. And nowadays, this thing is very important. Whenever I want to do something, I'll just try to press the button. This will, in order, it will release electric current, and this current will try to actuate these muscle wires, and these muscle wires in turn actuate basically the movement of these limbs or the links which have been connected to the limb. This makes the fingers of the hand move. Now, piezoelectric materials. Till this point of time, we were discussing about the smart material alloys. Now we are discussing about the piezoelectric materials. When stress is applied, it generates a voltage. You can see this. If you just connect an LED to your fan, this is the rotatory part. And as soon as it rotates or you press something, there is a piezoelectric material which, when it presses, it generates an electric current, and this electric current is used to illuminate the things. So, electric current, piezoelectric materials are those materials which, when affected upon by an external force, they tend to change or tend to generate an electric current which can be used, or even an electric reverse also, reverse piezoelectric. An electric current will try to change the physical properties of this material. Either it will try to enlarge or it will try to contract. Reverse piezoelectric. Now you can see this. An applied voltage will change the shape of the solid by a small amount, up to 4% change in the volume. Quartz watches, piezoelectric, US oscillators or ultrasonic oscillators are one of the examples for this. Now, applications. You would have seen your lighter, a gas lighter, which is available in almost all the houses, in all the kitchens. But have you ever learned how this functions? There is a piezoelectric material. Whenever it is impacted upon by a pressure, whenever you press the knob, a pressure is acted upon this piezoelectric material, and which in turn generates the electric current, which sparks. And this sparks basically lights the gas. Piezoelectric motor is there. A piezoelectric motor is based on the change in mechanical shape of a piezoelectric material. When tension is applied, the material produces ultrasonic or acoustic vibration and produces a linear or rotary motions. So these piezoelectric materials are used either way, either through current, change the volume, or changing the volume will generate a current. Both way it can be done. Now, magnetorestrictive materials. Magnetorestrictive materials means a restriction by magnetic field. Magnetorestriction is a property of ferromagnetic materials, ferromagnetic alloys even, that causes them to change their shape or dimensions during the process of magnetization. This is not new. This was about 2 centuries old in 1842 by James Joule. So what happens? Either we are able to change the shape or the dimensions, even the fluidity. Even we can restrict the flow of any liquid by using this magnetic field. Now, magnetorestrictive materials, actuators and sensors, magnetorestrictive transducers convert magnetic energy into mechanical energy. It can do that. EMF, electromotive force, it is basically onto this system itself. Vibration speaker technology. Whenever we speak, either on our mobile phones there is a pressure, which pressure changes the magnetic current, and this magnetic forces, and these magnetic forces, they changes the current, and this current is transmitted either through air or through wires, and at the other end, this thing is again changed back. This electric current is also changed back to the normal way, and we are able to hear the voice, such as we are doing right now. Using the highest power smart material installed in second, peel and stick. It can stick even, and it can become a formidable joint. No screws are required, no riveting is required, no welding is required. With this magnetic systems, we can have the formidable joints. Now, rheological materials. These are in liquid phase which can change state instantly. This is an extension of magnetorestrictive materials only. This is an extension of magnetic systems. Whenever these are in a liquid phase which can change state instantly through the application of electric or magnetic charge. These fluids may find application in brakes, shock absorbers, dampeners for vehicle seats, etc. Now, how do they function? You can see this. A flow is being maintained. A liquid is flowing whenever it is an off position. In case we make an on position, what happens? These ferrous particles, they become magnetized, and once they become magnetized, they tend to make a grid structure and they freeze. And once they freeze, the flow of the fluid stops. And again, whenever we eliminate the electric field or magnetic field, what happens? They again becomes liquid and the flow starts. So the flow can be restricted or it can be generated either by the input of electric currents or the magnetic currents. Now, what are these MRF applications? You can see this. This can be used in shock absorbers. They can be used to suddenly. You would have seen there are some uh, these fountains are there, and suddenly the fountain freezes. Especially in China, they are doing this. What they do is there is a suddenly they will create a human image. They will create some sort of image. Why? How it happens is there is a magnetorestrictive material, and suddenly what they will do is they will charge this with the magnetic field or with the electric field, and it becomes a solid shape. And the moment they remove this field, this becomes a liquid again. So you can see this is on a entertainment fountains, it has been there. You can see this braking mechanisms are there into the automobiles. If you press the brake, this brake generates an electric current through piezoelectric material, and this electric current that changes the fluid inside the master cylinder. This viscosity is changed, it becomes hard or it becomes liquid, more liquid, with less density. Now, thermoresponsive materials. Thermoresponsive materials, you would have seen the materials which are basically responding to temperature changes. ये कप्स तो देखे होंगे आपने, कप्स बिल्कुल ब्लैक है, and suddenly if you fill it with warm liquid, either tea or coffee, an image appears over these cups. This is because due to thermoresponsive paints. Thermal scanners. During the COVID time at the airport, these thermal scanners are used. They cannot check, or it is quite impossible to check the temperature of each and every passenger. So there are thermal scanners are fitted, and these thermal scanners are just seeing or just focusing on to the group of passengers whose temperature is more than the design temperature, that is marked as red onto the screen, and immediately that passenger is shifted out. So these are the thermoresponsive materials which change their change properties either with respect to color, either with respect to their size, either with respect to their viscosity. They are all known as thermoresponsive materials. Now, quantum tunneling composites, a very important thing. When compressed, it becomes perfect conductor, and when it is decompressed, it becomes a perfect insulator. In normal physics, an electron cannot pass through an insulation barrier. It is an insulator. In quantum physics theory, a wave of electron can pass through an insulator. That is what it is happening. In quantum physics, an electron can pass through an insulator, whereas in normal physics, it doesn't happen. What happens here is, whenever you press, it becomes a conductor. Whenever the pressure is removed, it becomes an insulator. Now you can see this. There is a mechanism here, quantum tunneling composite. Your phones are functioning over that. Whenever you touch the screen, it is because of this temperature, my finger temperature. If you try to touch this with a metal body, it is not going to function because my finger has got some temperature. For that, it is actuated. And this quantum tunneling composites, what happens? It tries to activate, and we are able to type onto the screen. Here you can see that there is a quantum tunneling composite is there, and as soon as the pressure is mounted over this, it becomes a conductor and the current flows. And as soon as we remove, it again becomes a insulator. Normally, this sort of systems are now not in our country, but in some of the foreign countries. They are fitted onto the platforms, railway platforms, or even the airports. And we are, whenever we are walking, we are stressing it. This stresses causes a count, and this count gives the exact number of passengers going in or coming out of a particular platform or particular airport. So this thing happens. Now, application of the smart materials. We have been talking about various sort of smart materials. Smart materials with respect to stress, strain, electric field, magnetic field, pH values, chemistry, quantum tunneling technologies, and all those things. But where you can use them. Smart switches and actuators, self-understanding, safety devices, fuses, alarms. Again, the reliability is very high of these smart materials. Artificial limbs, blood vessels and muscles. After, I've told you that within the next 3-4 years, we'll be entering into the fifth industrial revolution, where the robotics will play a major role. The robots will be there. You will no longer be dependent on maids to clean your houses, the waiters to serve your food into the restaurant. ATM, even an ATM is a robot. However, it is not into the human shape. Nowadays in Japan, they are having robotic dogs. They play with you, they love you as the normal dogs do, but with no strings attached. You don't have to care much for them except the engineering care. Adhesive tapes, bands. We just put tape onto some material, heat it, and it becomes a permanent joint. You cannot remove that. Even time-bound adhesives are there. Nowadays, you've got a beautiful paint in your house, and you want to celebrate the birthday of your child. You want to stick some of the balloons, you want to stick some of the write-ups onto the walls, but at the same time, you feel that this thing should not be spoiling your walls. So you have got this time-bound adhesives. After some time, it all automatically fades up. It's got an automatic healing property. Food packaging industry. Whenever you they are with the materials, they are filled up. Boxes filled up with the hot material. Nowadays, we are using some double layered materials in order to keep the contents hot. After some time, what is going to happen? The moment you open and it is de-stressed, the temperature of the metal will rise, which it has absorbed from the hot content. And immediately when the stress is removed, this hot temperature is again given back to this content and it becomes hot. Smart spoons. Smart spoons nowadays they are temperature sensitive polymers. They are used for the patients who are suffering from Parkinson disease. Parkinson disease में आपके हाथ पैर इस टाइप से शेक होते हैं. So if you are eating something with a spoon, you are definitely going to spill. Now this smart spoon, it leads the movement of your hand. Your hand is fitted, your hand is holding the end of the spoon and you are shaking your hand like this. But the front portion is not going to shake, it will become stiff. This movement of your hand is making this smart material temperature sensitive polymers as well as the motion sensitive polymers to freeze the front portion of the spoon. Smart nose and smart tongue, recognition of the characteristics. Smart nose, this is normally used to effect narcotics. Narcotics, in order to smell the narcotics, the nose it smells. And in case because of this fumes which are emitted out, these fumes try to change the pH value of the material, and this pH value definitely it is going to actuate the alarm that yes, the things are there. Nowadays, dogs are doing this. Mines, the IEDs, improvised explosive devices, explosive materials. Tongues are same way. They are used to test the composition. And these tongues, whenever they are brought into the composition, into the contact of any hot material, cold material, any solution, they try to activate because they try to change the characteristics of the material which they are made up of. Smart clothes. Smart clothes, a small jacket you are wearing. This jacket is basically, one second, I'll just try it. स्मार्ट क्लोथ्स में क्या होता है आप एक जैकेट पहने रखा है आपने यू आर वियरिंग अ जैकेट एंड दिस जैकेट it is temperature dependent. How it happens? If the outside temperature is hot, you will feel cold inside this. If the outside temperature is cold, you'll feel heat inside this. Why? Because the material which is fitted between two layers of this jacket, either it swells or compresses. When it is cold, it will swell. When it is hot, it will compress. So they are temperature dependent. And this temperature dependency, this basically changes the adaptability of the clothes. Now you can see this, a smart material wire is there. It is fitted with the lamp. As soon as the current is passed, it becomes curly, it becomes round. So with this sort of animated lamps, you can have sort of designer lamps you can have where the materials can change their shape, their sizes, and as soon as the electric current is passed or it is released of the electric current. The wings of the plane, as soon as the wings, they either senses the turbulence, they senses the temperature, they try to optimize their functioning, and accordingly they do this by virtue of these smart materials. Smart sensors, smart spoons, I have already told you. Smart nose, smart tongue, all these things are there. So with this, we come to an end of this session. And if you've got any queries, you can ask me. Hello. Professor Gyanin, I'm not getting your voice. I hope you're getting my voice. Professor Gyanin, are you getting my voice?
Hello, sir. We are getting your voice.
Okay, fine. Thank you.
Organizer is not responding. That is the problem.
Any queries onto this regard?
Yes, very nice. These things. I think liquid crystals are also belongs to the smart materials.
Yeah. Liquid crystals are the same thing. You know, liquid crystals, they either crystallize themselves or they are released by virtue of their electric field, magnetic field, as well as the pressure fields.
Especially electric and temperature, they become more transparent.
Yeah.
Where the pitch of the molecules controlled as a function of temperature or electric field.
Definitely.
Yeah. So presently you are working in the smart materials, sir.
No, I'm not working presently into the smart materials, but we are definitely working into one of the applications of the smart materials. One of my PhD scholars is working onto the application of the smart materials.
So where you are deploying for that?
Pardon?
Where you are applying for that?
Actually, we are applying for that in designing of some electric systems over the bridges, where if the speed of a vehicle is coming up and it is exceeding a particular range of the speed, definitely there will be the speed breakers will be coming up by themselves due to this magnetic field, and they will be hampering the speed, or they will be lowering down, or they will be forcing the vehicle to slow down the speed. Automatic coming up of the speed breakers and going down of the speed breakers, actuated by this mechanism of the magnetic field. This magnetic field will be sensed by the virtue of the speed, and this speed will be actuating the speed breakers up and down of the system.
Excellent, sir.
Okay.
Yes, real life application. Right.
Professor Gyanin, Professor Gyanendra, you are muted, I hope. हेलो हाँ कोई बात नहीं सो या तो मैं shall I move out of the system now? Okay, fine, I'll do that. Thank you all. Thank you very much to have a patient hearing onto this. And with this, I finish and I just sign off and take your leave. Thank you very much.